Hi, my name is Scott Jercich. I'm a retired civil engineer, and I became interested in the Internet of Things a couple of years ago. Now IoT is one of my hobbies. Rudy Heckfellner and Dan Nobe, two great instructors at Microfacturing Institutes, are familiar with some of the projects that I built after I took classes from MI, and so they asked me to talk a little bit about my experience learning IoT and share one of my projects with you. Now, I took two classes from MI. The first class was IoT for work, life, and play, and then I took their class on building a smart sprinkler system. These two classes really got me going in IoT because they introduced me to new applications and also technology that's needed for home automation. The classes introduced me to IoT Creator, really the foundation cloud-based application offered by MI. IoT Creator is an enhanced version of the Node-RED flow-based programming application. Now with this visual programming platform, you drag, drop, and you connect programming nodes together in a graphical user interface to build prototypes. Now these nodes are actually JavaScript that have been pre-written, so people using IoT Creator can assemble these nodes together to build prototypes with little or no programming experience. You simply drag, drop, and connect these nodes together, kind of like a jigsaw puzzle, as needed to achieve programmatically what you need to for your prototype. Also, since the programming is visual, it's very easy to make changes to the programs, also troubleshoot for bugs, and copy and reuse these node configurations in other projects. These classes introduced me to using the small but powerful Raspberry Pi computer with built-in Wi-Fi. Now the Pi is used to host a variety of applications used for automation, including Node-RED, DCONs, FOSCON, MQTT Broker, and VNC Viewer. The Pi also hosts a Zigbee gateway and a CONB2 hub, which allows use of several types of low-power Zigbee sensors that transmit data to IoT Creator in the cloud. Now the data can then be collected and processed in IoT Creator and used to wirelessly control devices for home automation and many other purposes. Also, IoT Creator allows you to quickly build a web interface so that you can control devices over the internet from anywhere in the world. For example, last month I was in another state for a few weeks, and California got a big hot spell. So I was able over the internet to interact with my smart sprinkler system here at home and change the timing on the stations appropriately for watering. Now the smart sprinkler class taught me quite a bit more about flow programming. We talked about key value pairs, integrating APIs into projects, and how to use a Shelly puck to control electrical switches using Wi-Fi and MQTT Broker. Now I know this all sounds a little bit complicated, but it's all covered pretty nicely in the MI courses. Now after I did quite a bit of home automation, my wife came to me one day and she said, you know, I'm getting tired of our propane running out right in the middle of a barbecue. So I decided I wanted to somehow monitor the propane in the tank under our barbecue so we would know when the propane was getting low. Now the problem was I couldn't find a Zigbee-based sensor that would monitor the volume of propane in the tank. So I realized I needed to somehow create my own sensor that would monitor the tank volume, also transmit the data to IoT Creator in the cloud, have the volume display in real time in IoT Creator, and also I wanted it to display on my smartphone. I wanted, in addition, to have an LED illuminate at the barbecue when the volume got low, and finally when the volume got down to 5%, I wanted to receive a text message warning me of this so that I could go and refill the tank before the next barbecue. So after doing some research, I realized I could use what is called a load cell to continuously monitor the weight of the propane tank in the barbecue, and then send this data with a wire to a Wi-Fi equipped microprocessor at the barbecue, and from there transfer this data by way of MQTT to IoT Creator in the cloud. Here's a diagram that shows the overall project. Starting from the left, you can see the propane tank resting on an electronic scale I built using a load cell. A load cell is a metal bar with a hole drilled in the center to weaken the section. The weight of the propane tank bends this bar downward, causing a very thin wire bonded to the top of the metal bar to stretch. Shrinkage in diameter of this thin wire results in a corresponding increase in electrical resistance in the wire that can be measured by an electronic circuit known as a Wheatstone bridge. This Wheatstone bridge is part of an integrated circuit you can see in the diagram labeled HX711. The HX711 converts these small resistance changes into small changes in voltage, amplifies the values, and converts them to standard digital values that can be used by a microprocessor. An ESP8266 microprocessor that you can see to the right of the propane tank receives these digital values from a wire and then transmits this data by way of Wi-Fi and MQTT broker to IoT Creator in the cloud. Now the box on the far right of the diagram shows this data received in IoT Creator, where the digital values are converted into gross and tier weights and displayed in IoT Creator. IoT Creator then sends a text message to my smartphone when the propane tank drops to 5%. I mentioned earlier that I wanted an LED to illuminate at the barbecue when the volume of propane dropped to 5%. This diagram shows how this is done. The weight of the propane is constantly monitored in IoT Creator. When the volume drops to 5%, a message is sent from IoT Creator by way of MQTT, the internet, and finally Wi-Fi back to the microprocessor located at the barbecue. The message instructs the ESP8266 microprocessor to illuminate the LED. Now, why don't we take a look at the project? Here is the electronic scale and black box containing the microprocessor and LED. Inside the black box, you can see the ESP8266 microprocessor attached to a 110 to 9 volt converter that powers the microprocessor. The yellow wire sticking up is an extension of the built-in Wi-Fi antenna on the microprocessor. The brown wire feeds data from the electronic scale to the microprocessor. You can see the blue LED at the bottom edge of the black box. Here is the electronic scale. Under the propane tank support, you can see the load cell sandwiched between the tank support and the scale base. Turning the scale upside down, you can see the HX711 analog to digital converter that receives data from the load cell and feeds it to the microprocessor. Using VNC Viewer on my smartphone, I'm able to see the same thing I can see in IoT Creator. Here you can graphically see a gauge designed to show the amount of weight placed on an electronic scale in real time. I programmed a switch in IoT Creator to allow me to test the LED. In actual operation, the LED will be illuminated by a command in IoT Creator as previously mentioned. You can see when I place a weight on the electronic scale, the gauge responds, showing the weight being at 14.6 pounds. Here is the propane bottle sitting on the electronic scale. You can see that the propane bottle weighs 32.9 pounds. I installed the project under the barbecue. Here you can see the black box sitting under the barbecue and also the blue LED. It's in a dry and cool place. Now if we step around the barbecue and take a look underneath, we can see the black box with a power cord attached. And below this, we can see the propane bottle sitting on the electronic scale. Well, that's my project. I hope you found it interesting. And if you would like to get into the Internet of Things like I did, I strongly recommend you consider taking a couple of classes from microfactoring institutes.